Let's see the example on traffic light. So it's a one-way traffic light with the pedestrian signals. So we know this traffic light have the three outputs. Okay. So red, yellow and green. So these are the three signals in the traffic light, and we have two more outputs for the pedestrian signals to cross the road. So this is a one-way traffic light. So we have one start switch and one stop switch to control this signals. Okay, once you give a start signal, first red light will turn on for 5 seconds, and then yellow light will turn on for 2 seconds, and then green signal will turn on for 5 seconds. So this timings you can change. This is just for an example. I am taking for red 5 seconds, yellow signal for 2 seconds and green signal for 5 seconds. And for a pedestrian signals, so whenever the red signal is there, then that green pedestrian will turn on. Okay, and for balance signals like yellow and green, whenever the yellow signal is there, green signal is there, then your pedestrian red signal will turn on. Okay. So green signal here will turn on after 1 second delay of red signal. Once the red signal is on, after 1 second we need to turn on this crossing symbol. Okay. And then red will be on once the red signal is goes off. Once the yellow signal is come, that time the stop signal has to come for the pedestrians. So let's see this in the software. So in this software, we need to select the controller which have 5 outputs, which will support for the 5 outputs, because in my program, in that example, have 5 outputs. So if you select this series, here you can see that output is only 4, but we need a 5 outputs. So what you can do, you can expand, you can select this one, here also okay, 4 outputs are there. So you have to go with the B series B. So if you see, you can choose a controller which have the more than 4 output. Okay, so this series have this more than 4 outputs. So I'll select the controller. Okay, so double click on this controller, circuit diagram will open, this window will open. So here I can use maximum 8 outputs. Okay, so first let's take an input signal, input start and stop. So this is my start signal and this is I2. Change the address and give a comment as stop. So this is my stop signal. I am going to take the NC contact. Okay, and then I am considering the start and stop is a push button. So I want to latch this to hold the input. So I am taking one marker here, means memory bit. So I will name it as a start cycle, and then I'll take the contact memory and I'll connect parallel to the start input. Okay, so once the start cycle is there, then I need to turn on my red signal. For that I'm going to take an output Q01 as a red signal, and the same time, okay, same time I need to run one more timer, that is T1. Okay, so take a T1 timer. So this I'm going to name it as a red timer. Okay, so once the timer gives an output, okay, this I'm going to take it for a 5 second. Once it reaches the 5 second, I need to turn off the red signal here. So here I'm going to take the NC contact of the timer. So I'll take NC contact of the timer. So then connect this one to the start cycle. Okay, so once the red signal is there, red timer is done. Once the timer is done, I need to turn on the yellow signal. So I'm going to take one more coil here, that is Q02 for a yellow. This yellow signal should turn on for 2 seconds. For that, I'm going to take one more timer T02 for the yellow signal timer. Okay, so this parameter I'm going to set it to the 2 second. Once the timer is done, you need to turn off the yellow signal. For that, I'm going to take one contact here, NC contact T2, and then connect parallelly to the red timer output. Okay. So once the yellow timer output is there, I need to turn on the green signal. So for that, I am going to take one more output here, Q03 for the green signal. Okay, so this green signal to turn on 5 seconds, it has to on for the 5 seconds. So I am going to take one more timer T3 for a green signal. Okay, so I am name comment as a green timer, and in the parameter set it for the 5 seconds. Okay, so once this is there, once it is done, you need to repeat the process. Means again, after this green light, yellow signal to turn, it should turn on. So that what I am going to do here, I will take an NC contact. So in that first timer, red timer is there, no? There I will take one NC contact of the T3 timer. Okay, and here you can observe one thing. I am not going to take any NC contact for the turning of this Q3. As you seen before, we have taken the NC contact here for the turning of the signal. But here I am not taking. Why? Because once the, So once this is done, once that green timer is done, signal is there, then it will break the connection for the red timer. So once the red timer is break, then here it will be 0. So it will reset to 0. Once this timer is reset to 0, all the output will be reset to 0. So that's the reason I am not taking the any NC contact for the green coil. Okay, so this is for the, I'll show you. Okay, so this is for the signals, right? Yellow and green. Okay, in this scenario we have this pedestrian signals also. So for that I am going to write a logic here. So first we need to take a start cycle. So once the start cycle is there, initially red signal will be on, red pedestrian signal. So for that I am going to change it as a output 5. Output 4 you can take any number, output 5 also is fine. So here name it as a pedestrian red. Okay, so then I'll take one timer output of the red signal. Okay, so let's take the output of the, so this I'll delete. So let's take the output of the red signal. Okay, so once the red signal is there, I need to run the timer to giving the 1 delay second. So for that I am going to take the T4. Here I'll name it as a pedestrian timer. Okay, so then this timer output I am going to give for the green signal of the pedestrians. So this is, I'll name it as a, I'll address first for Q5 and then I'll give a comment as a pedestrian green. So this timer address is T4. Okay, so now the logic is done. Okay, So if you want, miss, we'll analyze the, once again we'll analyze the logic here. Okay, I'll start with the start cycle. Once you give a start signal, so this will be on. Once the signal is on, red signal will turn on. Once this is on, the timer also will run parallelly because I have taken the parallel connection for the red. So once it is done, once the timer is done, you will get a signal at red timer T01. So this will break the connection, means red signal will turn off and yellow signal will turn on, and a parallelly yellow timer will run. Once this timer is done, here I have taken the NC contact, so this will turn off, Q02 will turn off and Q3 will turn on. At the same time, this timer also will run for 5 seconds. After 5 seconds, here I have taken NC contact, so it will break. Once this is break, red timer will reset to 0, then red signal will turn on because here NC contact. So once the timer resetted, here it will connect again. So once the connection is made, red signal will on and the cycle will start repeating until you press the stop switch. And pedestrian signals also same. So once the cycle is there, pedestrian red signal will be on. So once the red output is there, Q01 is on after 1 second delay. So for this I have taken 1 second delay. After that, green will on, pedestrian green signal will on, and once it is on for 4 seconds. After that, red signal will be turned off. After that, this timer also will reset to 0. Okay, and this will be in the continuous process until you press the stop switch. So in the parameter, let's set the 1 second for the pedestrian green. Let's go to the simulation and let's check this code. Go to the simulation tab, click on this tab and then click on this run. And in IR function, I am going to take start and stop as a push button. And then this is the I inputs, and go to the display, select the output. So you can see the outputs here, Q1, Q2, Q3, Q4 and Q5. So these are the red, yellow, green, and this one pedestrian red and green signal. So what I'll do, I'll change this address. I'll go to the circuit diagram. Let's go to the circuit diagram. So here, let's change this address for the 5. So here I'll give a red. So this will be easy to see the output. Because of that, I'm changing this address to Q5 and Q6. So this will be green. Okay, let's go to the simulation. So click on this Q outputs. So here you can see red, yellow, green is there. This side, pedestrian red and green signal is there. Let's give the start. Give a start signal. So you can see now red is on, pedestrian red is there. Okay. Yeah, here you can see it both was on now. Once it comes to red signal, you can see here both are on because of the, I have taken a direct connection. Here I am not taking any NC contact to turn off this pedestrian red. Okay, so let's go to the circuit diagram. Here I have missed to take the NC contact of the output, that is pedestrian green. So here I will take the NC contact of Q6. Okay, so now we'll see in the simulation. Give a run, give start signal. Now you can see red is on. After this, here pedestrian green will be on. After 5 seconds, yellow signal will come and here red. And after that, green for 5 seconds. After that, again it will repeat. Red will on, and here you can see it is changing. Now pedestrian green signal is there. After that, it will go back to the red signal. So this is the one-way traffic light with the pedestrian signals. So here I used 3 timers for the signals, traffic signals, and 1 timer for the pedestrian signals.